Welcome to video 9.9c, more trig ratio problems. So I've got two examples. Example 4, find x and y and round to the nearest tenth. Okay, so x is this dimension, y is this dimension. I went ahead and called z the big dimension. I'm going to use that later in my problem. All right, so I've got a right triangle. What I'll do is I'll circle this, make that be my reference angle, and then label. So this will be the hypotenuse, this will be the opposite, and this will be the adjacent. So there's typically three things involved in trigonometry: an angle and two sides. And you need to know two of those three things. So I know this and this, so I can solve for this. So just reminding you of SOHCAHTOA. So somebody I know and somebody I'm looking for. Opposite and adjacent. Who has opposite and adjacent? Well, it's tangent. So that's how I know which trig ratio to use. Somebody I know and somebody I'm looking for. All right, so I'm going to set up an equation with tangent. So I'm going to say the tangent of 58 degrees equals opposite over adjacent 10 over x. And what I'm going to do is just solve that for x. I'll multiply each side by x. So x times the tangent of 58 degrees equals 10. And I'll just divide each side by the tangent of 58. So x equals 10 divided by the tangent of 58 degrees. Then I'll take out my calculator. If you've got a graphing calculator, press mode and make sure it's in degree mode. It does default to radian mode. You should be safe with your TI-30. So I'm good. So I'm going to go 10 divided by tangent of 58 degrees and get 6.249. I just want a few extra decimals. Okay. Now I've got to find y. Oh, they said to round to 1, so x is approximately 6.2. I'll use this in intermediate results. All right, now I want to find y, but y is not part of a right triangle. So what I'm going to do is actually find z. I'm going to look at this big right triangle. And once I get z, I'll subtract away x to get y. So that's going to be my strategy. Okay, so now this will be my reference angle. Again, this will be my opposite. The whole z will be my adjacent now. All right, so let's again, somebody I know and somebody I'm looking for, opposite and adjacent, that's going to be tangent again. So the tangent of 32 degrees equals 10 over z. So again, just like I did before, z will end up being 10 over the tangent of 32 degrees. Z will be about 10 divided by tangent of 32, 16.00. Now they don't care about z, they cared about y. So y is going to be z minus x. So y will be 16.00 minus 6.25. We'll just punch that out. So 16 minus 6.25. And I get 9.75, round to the nearest tenth, 9.8. Okay, so kind of a nifty problem. Example 5. This will definitely appear on a future quiz and test. Students tend to get it wrong, so pay close attention to this one. So sine of b is 5 over 13. So right away, b is my reference angle. All right, then I go across here. I'll call that the hypotenuse. I'll call that the opposite. And I'll call that the adjacent. Okay. I'm trying to find AB. All right. Since these numbers are different than these numbers, what I'm going to do is draw a different triangle representing these dimensions. So I'll just draw a different triangle. So again, I'll have a B over here, a C over here, an A over here. I'll reference that. Again, the hypotenuse, the opposite, and the adjacent. So now using these numbers over here, opposite over hypotenuse is 5 over 13. Well, I happen to know the 5, 12, 13 Pythagorean triple, so in this small triangle over here, I've got a 13. I'm sorry, I've got a 12. All right, well, I don't care about this little triangle, I care about this big triangle. Ooh, how did I get from 5 to 15? I multiplied by 3. How will I get from this side to this side? I will multiply by 3. So 12 times 3 is 36. So AB equals 36. Again, totally based on similarity and ratios of corresponding sides being equivalent. So there you have it. 2 more examples involving trig ratios.